So today we were looking at solving. Emma, can you hit the right light switch, please? Awesome. Today we were looking at solving radical equations and inequalities. Okay, so we know what radicals are, right? Those are like our square roots, cube roots, all that stuff.
Yeah.
And then inequalities don't really change a whole lot. They just add a little bit of extra work at the end. So really what we're going to do is look at a couple of different, 5 maybe, examples of different situations that you'll see when you have to solve these radicals. Yeah, 5 or so. All right, so our learning targets and all that good stuff. Before we look at like too many examples, we're just going to go through what the book gives as a step-by-step process to solve these. Hopefully this is something that isn't a surprise and that we've seen before, but just to make sure we're all on the same page, we'll go through this step-by-step process. So the first thing we have to do to solve an equation that has a radical involved is get rid of everything around the radical. Okay? So in this case, we just have a times 2 on the outside of the radical, but sometimes we'll have like a +4 outside the radical or something else going on. We need to clear everything on that side except for the radical. So first, we would divide each side by 2. Our second step, after we isolate the radical, get it all by itself, raise each side of the equation to the same exponent to eliminate the radical. So this time we have a square root. So we are going to raise each side to the second power. If we had a cube root, what would we raise each side to?
3.
Right, to the third. Or if we had a fourth root, to the fourth. We are undoing that radical. X plus 1 equals 4. Subtract 1 from each side. And we would find that x equals 3. Now, that last step says check your solution, and that's not just like a double check. Well, it is like a double check to make sure you're right, but it's not just like a cheesy last step of, oh, just make sure you did all your steps right. We actually do need to pay attention and check our solution every time, because what would happen if, well, there are going to be situations where our answer might be something like plus or minus 3. And if we put -3 into this radical, would that work? No, we'd end up with a square root of -2, which we cannot do. So obviously in this case, the only solution that we could have is +3, right? But there are going to be cases where we have to, or where we have a plus or minus in our answer, or we have multiple answers. We need to make sure that we are checking each one of those to make sure that they work. So in this case, example number 1, we've got a minus sign, or -1 here. First thing we've got to do is get rid of everything that is around the radical. This is the cube root. Now remember, the cube root is the same thing as this to the 1/3. If you like to think about it like that, that's totally fine. That you don't have to write it this step, but it makes it a little bit more clear to see that we are getting rid of that cube root, or getting rid of that 1/3 by raising it each side to the third power. Okay. Let's see. 3 times 3 is 9. Times 3 is 27. Add 9 to each side. Give us
36.
Would give us what?
36.
36. So then x would equal 18. Right? Is that what you said, Ryan?
Yeah.
18. Okay. Now we can. We don't have to full out like plug this answer in, but if we just quick check, 2 times 18 gives 36 minus 9. We're still in the positive inside that cube root, so we're in good shape. Let's look at another term, which you might have heard of in Algebra 2A. I'm not exactly sure, but still might have talked about it. But extraneous solutions, okay? Notice that extra is all in caps, not just to be extra, but because that'll tell you what it means. So, an extraneous solution. Raising each side of an equation to the same exponent may introduce solutions that are not solutions. So, like we talked about, if we have something that comes down to x is plus or minus 3, either the plus 3 or the minus 3 might not work if we have square root of something up here. Okay, I know I'm being vague, but we'll look at an example. Exponent may introduce solutions that are not solutions of the original equation. These solutions are called extraneous or extra solutions. When you use this procedure, you should always check each apparent solution in the original equation. All right, so that's just the way that the book says. Make sure you check your answers. Make sure your answers make sense. So let's look at another example. The square root is already isolated on that side, so what would our next step be?
Yes, square root.
We need to square both sides, yep. Now, one side note, what I saw a lot of people do on the quiz, whether it was when I actually graded it or just when we were talking through the quiz, is they took this second power and they distributed it to the x and to the 1. Why are we not allowed to do that in this situation?
Yeah, I think they found it.
You have to FOIL it out, right? Since there's that plus sign in the middle, we can't just distribute that squares, that exponent of 2. So we do have to FOIL it. We should get x squared plus 2x plus 1. Right? We add the n terms, multiply, etc. Subtract 7x from each side. Now, what are we going to need to do to, we need to get this set equal to 0 so that we can factor it. So we're getting everything over to the left side of that equation so we can factor. So now I'm going to come right up here. We would have x squared minus 5x, and then we have a positive 1 minus 15 minus 14 equals 0. Now we can factor it to find the solutions.
Could we use the quadratic formula?
You could. Do you want to?
No. We know
should we call Mrs. Stone and should we sing?
Yeah, that's a great idea.
You guys have learned the song?
Do you know? Okay. No. I got a new song.
First song was
I can't believe I forgot about this.
We didn't do an icebreaker today.
This will be our break instead.
Your YouTube channel.
This is the one we all need to learn.
Oh, sound.
Yeah, but vacation rental by owner?
What?
I can't hear it.
I can't hear you.
What is going on? How is that so bad?
Try to mess with the little dials. You have the ones underneath your.
I know, but like.
You gotta hold it a certain half of that.
Good Tom.
Maybe just try from your computer. Good luck.
Maybe you should just bring your guitar in.
Yeah. You want a guitar?
Don't tempt me. 2b squared over 2.
I want it now.
Nope.
Nope. Oh, One Direction.
Did you hear it? Could you hear it? It was one thing.
No.
Okay.
I got that one thing so good.
Sorry, virtual students. It's not fun review day, so we don't get that.
Sorry.
Okay, anyway, we could use some quadratic formula. Yes, we could. That was the point of all that. Where was I? Oh, yeah. But we're not going to. We're just going to think of factoring. So, good thing we listened to that song about the quadratic. We have negative 14 on the end. So we know that we need a plus and a minus here in the middle. That's the only way to multiply together and get negative 14. Minus 7 plus 2, I agree. 5 minus, wait a second, I put plus 5.
Whoa.
Whoa.
It's not erasing. It's not erasing. I shouldn't have switched to YouTube. This is glitching big time now. There we go. So 2 minus 7 will give us that negative 5 in the middle. 2 times the negative 7 will give us negative 14. So our answer would be negative 2, positive 7. Right? That's what would solve this equation. Now, this is where we need to plug stuff in and make sure that we don't have any extraneous solutions. Negative 2, we look at our square root. Negative 2 multiplied by 7 will give us negative 14. Plus 15, we're still in the positive. Positive 1, we're all good. 7 and 7 is positive. Right? So we would be all set there. Okay, but you could see a situation where if they made it so it came out to be like negative 3 right here, then we would have a negative inside the square root. But we still need to check, even though they made it nice. I'll just go through the start of this one. I won't actually solve the entire thing. How do we start out trying to solve this problem? Because we have a square root on both sides. So what would our first step want to be, Faith?
Just square both sides. And like completely get rid of the
Yep, that's what we would want to do. We'd want to square both sides. I mean, our thinking would be that we square the right side, because that would get rid of the square root on the right side. But what would happen is, yeah, we would square both sides. Okay, and then we would have to rewrite this. And we would have to foil that. Right, we would have to foil. Would you like me to go through foiling that, or?
Yeah.
Yeah.
I don't like to say yeah.
Okay, sure. So, we start with our first, when we multiply any two square roots that are the exact same by each other, square root drops. So just x plus 2. Plus square root of x plus 2, right? Because when we multiply square root of x plus 2 times 1, we just get root x plus 2. We would simplify this then to x plus, we have a plus 1 here and a plus 2 here.
Okay.
And then how many square roots of x plus 2 do we have? 2.
Okay.
Interesting.
I like it a lot. That seems doable.
Now what we would need to do is isolate the square root. Now we would start our steps really all over again. We would need to isolate this square root, square both sides, and then we would be able to find x. I can keep going.
Yeah.
Yeah. Oh, yeah.
But I'm running over. Can I erase these steps above, or are people still writing? So we have x plus 3. We need to isolate the square root. So if we subtract x from each side, 3 minus, that gives 2 x's over here. Subtracting 3 from each side. Let's see, 3 minus 3, we just get rid of this one. You following?
Yeah.
Right. Divide by 2.
You get negative 2. Oh, yeah, here.
Just negative x.
These are very
You'll feel super smart after you do this. Square both sides, get rid of our square root. Now I wrote it down. We don't need to write this negative sign anymore because no matter what comes out of that x squared is going to be positive. And lastly, we would need to, since we have an x squared and an x, we would have to, well, we'll go this way. We'd have to get x, or this whole thing set equal to 0 so we can factor it. So we need to bring both of these to our other side. So we have 0 equals x squared minus x minus 2. And now we are able to factor. It's going to have to be plus 1 minus 2. So our answers would be negative 1 and positive 2. Which both, they both work? Yeah, they both would work if we look at these square roots.
That was a long one.
That was a pretty cool problem.
That was really cool.
Super sweet.
I really like
I
that.
feel smart. Super rad.
You should.
I do.
I'm rad.
I think you should feel smarter though, because you did it.
This is my 3rd time.
Okay.
Yeah.
I beat those people on this true.
Anyway. 2 more examples.
Oh,
We good?
Oh, we have flipping.
Ooh.
2 more examples. So this is not shown.
No,
The format that Google has for me to put exponents in is not awesome. Our first step, we need to get rid of everything that is not under that 3/4. So subtract 2 from both sides. Well, whoops. Now, how would we bring that 3/4? How do we get rid of that 3/4 in the exponent? Multiply each side by what?
4/3.
4/3. Good job.
Okay.
Can we do 18?
Yeah, it's 16.
Is it really?
Yeah.
Ryan's always one step
Oh,
ahead.
I like this one.
And on each of the homework problems today, it'll ask you to check. So you can just plug that right back in. All right, last type of problem with the inequality.
Oh,
Right?
No.
Okay, you guys are fine. It doesn't change anything except for one extra step at the end.
we are so good.
So, same sequence. We need to get that square root all by itself. That's supposed to be. So I'm going to move over here to make sure I've got room. So that means we have square root of x minus 1 less than or equal to. Let's see, 12 divided by 3,
4.
4. Now we need to get rid of our square root. x is less than or equal to 17.
So any number that's less than 17 words.
Where?
Like as a
So I'm supposed to flip the inequality? Did I forget to?
No, only if you like multiply by a negative or something.
Right. Yeah. Yep. And I don't think we go that far. I'm hoping. No, actually, in the problems that we do in the homework, you shouldn't have to flip the inequality. But that is the situation where you can. Okay. Now, this is where we need to do one more little bit of checking. What would not work in this square root?
Anything over 17.
Anything over 17. Now, well, I didn't ask that one. Let me think.
Wouldn't a negative number not work?
Yes, that's what I was trying to get at. I don't know if Delaney said that or if Facebook. Yes, a negative number would not work. Would 0 work?
Yes.
0 would? So
It's
can
less
x be
than 17.
can x be 0? No, because we'd have a negative. Could x be 1?
Yeah.
Yeah, we'd be okay. Could it be less than 1? Like between 0 and 1?
Yeah.
It could? No, we'd still have a negative. So we need to kind of check our parameters with that radical. Because we would have 1 is less than or equal to x is less than or equal to 17. Okay? Because we could not have a number, we could have 1, so we're less than or equal to, but we could not have like 1/2. 1/2 would not work for us. So we need to check to make sure that whatever we get here completely fits what can happen in the radical. If it completely fits what can happen in the radical, then we're all good, we can leave it. But if it doesn't totally fit what can happen in the radical, like if we just left it as this, that would imply that -2 could go in for x, so it would be 5. Well, that's not true. So we need to set these parameters. See, it's not that bad.
Yeah.
Also, that lesson was pretty quick. 23 minutes, but we took, well, I took 3 minutes trying to do that video work. 20 minutes is bad. There's the class kick. The class kick is like 6 problems or something, so a little bit longer. But, you know,